My name is Dominic Pizzuto, and I've been hooked on FIRST robotics since I first got involved in 3rd grade. Ever since then, my life has pretty much revolved around robotics. During my years in FIRST LEGO League, I always remember seeing the high school students working on this massive machine, and always hoping that someday I'd get to do that too. 10 years later, and my dream has come true. I am currently on Team Max, our high school's first robotics team. I've actually been a member of FIRST Team Max since 8th grade, and now have come to be the head of programming and electrical systems for our team. Going into build season this year, one of my main intentions was to bring something new to the table that our team hasn't really seen before. I decided to tackle a challenge we've never really addressed before, making human-robot interactions much simpler for the users. I quickly realized there was a lot I could do to address these problems. One of the first issues I set out to solve was the team's dependence on me to run any motor at all. I'm essentially our team's sole programmer, and whenever any team members needed a motor tested, I'd have to bring an entire electronics board, write code, and wait several minutes while everything deployed. This slowed things down in the build process greatly. With this in mind, I set out with a design to create a device that would allow me to connect a single motor to a battery, switch directions of the motor, and run it at variable speeds. An additional challenge that I set for myself was that I was determined to make the device entirely out of parts we already owned. After some research, I concluded that this was definitely feasible. To allow the motor to be controlled at different speeds and with a toggle between forward and reverse, I used an old Jaguar motor controller. The problem I then faced was how to control and send signals to the Jaguar. After a bit more research, I decided to use an Arduino microprocessor. Our programming mentor happened to have one of these, and after explaining my plan to him, he volunteered to contribute the Arduino. Another challenge to me was that I've never worked with an Arduino before, so I had no idea how to program it. My programming mentor gave me a brief explanation of the basics, but intentionally left some parts vague so that I'd have to figure out a lot of the code myself. After some experimenting, I finally had working code for the Arduino. All that remained were the buttons the operator would interact with, which were added to a project box. I even added in a few LEDs that indicated the motor's direction and speed. After realizing the potential the Arduino had to simplify robot user interactions, I decided to incorporate one into this year's control systems as well. Traditionally, all of the controls for the robot were assigned to various buttons on a joystick. We never used additional buttons. Over the years, I had received a few complaints from team members about the joysticks being convoluted with buttons. Unfortunately, I didn't have the know-how to fix it. After getting some experience with the Arduino and the creation of the motor controller, I realized I'd really be able to use one to optimize the control system for this year's robot. I was able to design a box that housed several switches. At this point, however, I was faced with another problem. I had no idea how to make the Arduino communicate with our code in LabVIEW. Just as before, my programming mentor explained the basics, but not the specifics. Soon after, I went to work and had serial communications established between the two in a few days. This new box was far easier to interact with than the convoluted joysticks buttons. Other implementations to improve human-robot interaction I worked on include wiring the robot's Jaguars with a CAN bus to allow users to more easily access data, as well as improving the robot's code to make it easier to manipulate a given motor. To be honest, having a successful FIRST team is a lot like wiring a robot with a CAN bus system. Each part needs to work and be connected to the other parts, or else the entire system fails. For this reason, our team places a huge emphasis on teamwork. One excellent example of this is our weekly slushy nights, where the team gathers together to discuss the status of all the projects that are being worked on. Cooperation and teamwork is vital to our team's success. In fact, the ability to work together is so significant on our team that we dedicate several days before build season just to building teamwork skills. This past year, we held a video game tournament that was open to all current and new-coming members to the team. Even one of our team captains, Mr. Robert Cormier, participated, and close bonds were formed between all existing members. In addition to this, we started a new tradition last year, where we invite teams from the nearby towns to join us the night before kickoff for an event Team Max likes to call Lord of the Bling. Here, team members make friends with others and compete in minute-to-win-it challenges for bling. It's honestly one of the most fun nights of the whole season, and following the games, we all go to our school's lecture hall where we watch Galaxy Quest, a tradition that's existed since our team's beginning. This year, one of the most beloved mentors on our team, Mr. Vern Van Fleet, went in for open heart surgery in the middle of build season. He's incredibly committed to the team, and it seemed difficult for him that he couldn't attend meetings for many weeks after the operation. To raise his spirits, our entire team gathered together one Sunday and put together a dance video to the tune of You Give Love a Bad Name. Needless to say, he greatly enjoyed the video, and everyone on our team clearly felt closer together after the video's completion. Our team is like a really huge family that looks out for each other all the time, and I'm blessed to have been part of such a great team. An old saying on our team states that once you've been hit by the max wave,